Assalamu alaikum dear students. In the series of learning C programming, we are discussing structures in C. In the previous video, we have discussed array of structures. In that video, we have discussed why do we need array of structures. What is array of structures? That all have been discussed very thoroughly and minutely in that video. And in today's video, we are going to discuss what is pointer to structure, or what is pointer structure, or we can say how we can access the element by variables of the structure through their pointers. That all will be discussed in today's video with the help of the example. चूंकि अच्छी तरह structure CS तो पकड़स वीडियोस में मुझे ऐसे array of structure क्या गो तो ऐसे क्या चाहिए पेमान ज़रूरत array of structure तो अजकिस वीडियोस में मुझे pointer to structure क्या गो तो structure pointer या structure pointer कच्चे बनान तो अज किसके हैकान variables यम structure variables आसान चे तिम किसके access करान through their pointers that all will be discussed in today's video. So let us start today's topic, that is pointer to structure. First of all, I will define here a structure, the same example which I have discussed in previous videos. For example, subtract student and roll number, care, name of 20, float, marks, here I have defined a structure with three members: roll number after integer, name, character type, and marks, float type. So no, we can write these brackets, these curly braces here or here. We can also write these curly braces here. It is also correct. So let us discuss it. Our topic is pointer to structure. We can, as we have already discussed in the previous video, we can define we can declare the variables of the structure here as well. For example, this is also correct. Here I have declared the variables of the structure. Or you can say the objects of the structure. As is the objects of structure, this structure, student. And we can also declare the structure variables here as well. For example, I can write also subtract student, I can only S, and then I can also declare here as well void man subtract student S1. Whenever we declare the structure variables, or we can say outside this main program, outside this main function, it is global in nature. We know here I have declared this S. Here the S is the structure variable, or you can say it is the object of subtract student, because both subtract student, from this subtract student is the data type. That means S is the variable of data type subtract student. As we know that subtract student is a user-defined data type. This complete subtract student is the data type, name of the structure. Or you can say subtract student is the data type, S. This means that S is the variable, or you can say S is the object of subtract student type, because it is user-defined data type. Here I have declared this subtract student outside this body of the man, or you can say I have declared at any outside this main function. It is global in nature. We know that the global variables can be accessed from any function of this structure, from any function of the program. For example, if this program have 5 functions, we can access this S, this subtract student S from any function, from anywhere. from anywhere of the program. That means all the 5 functions. Suppose this program contains 5 functions. All the 5 functions can access this S variable. Because it is global in nature. And this subtract student, this is global variable, global. And this is local. That means this variable, subtract student, is visible only within this main function. We can access this only within this main function. We cannot access this from outside this main function. So we can say that it is, if we declare the subtract variable outside this main function, it is global in nature. And if we declare it inside this, it is local in function. And this one, if I declare here S, it is also local to this. Okay? And this is global declaration of the structure variable. Now, our today's topic is pointer. How we can declare a pointer? Pointer. For example, I have declared here this subtract student S1. S1 is the variable, or you can say S1 is the object of this structure, and it contains 3 members. S1 contains roll number, marks, name, and marks. So whenever we can say here, if we declare a pointer, here's a pointer to structure. We know what is pointer. Actually, what is pointer? Pointer is a special variable that holds the address of another variable. That means pointers are used to hold the address. We cannot store values in the pointer. Pointer are the variables. We know that. What are variables? Variables are actually the memory locations where we store the values, But the pointers are also their variables. They are special variables. Why they are special? Because they hold the address of other variables. They store the address of other variables. For example, if here I will declare if int A, this declaration tells the compiler that A is the name of the memory location. For example, this is in the memory. A is the name of the memory location. And which can hold the integer value. And if we declare this at, for example, compile the installation, A equal to 5. That means A is the name of the memory location. A is the name of the memory location that holds the integer value, and this value is 5. That means through this declaration, 4 bytes of the memory will be allocated by the memory manager for this A. For this A, 4 bytes of the memory will be allocated. For example, we know that a variable have 3 properties, attributes, and set this with address. This is value, and this is name. A variable have these 3 properties or attributes. Name of the A is the name of the variable, 5 is the value that is stored in A, and third one is the address, which is going to be generated by the operating system, automatically. So, for example, here this 1000 is the address of this A. 1000 is the address of this memory location. Actually, the addresses are in the hexadecimal format. I have already told you in previous videos that addresses are actually in the hexadecimal format. But for simplicity here, I have written it in integers for simplicity, for understanding purpose. I suppose that 1000 is the address of this A. Now, what is A? If I want to store this address, address of A, where it can be stored. The addresses are going to be stored in the pointers. For example, how we can declare int P equal to T equal to address of A. What does this declaration mean? That P is the pointer. P is the pointer to integer. That means P is also a variable here. P is also a variable. That stores the address of A. What is the address of A? Here, the address of A, here the address of A is 1000. That means 1000 is going to be stored in A. Now it means that this P points to A. P is a pointer. Because the pointer is the variable that stores the address of A. What is the address of A? Address of A is 1000. Address of A is 1000. That is going to be stored in P. That is going to be stored E. This asterisk tells the compiler that P is the pointer. P is the pointer. We store the address of integer variable. We store the address of integer variable. Here, integer variable is A and address of A is 1000. And that means 1000 is going to be stored in this P. And this means that P points to A. P points to A. This is a simple declaration and initialization of the pointers. But now here we know that what is int? Int is the data type. Data type means the type of the data that is going to be stored. Here is integer variable. That means integer value is going to be stored in A. And similarly, for example, if I declare the pointer for this variable, pointer for this structure, pointer for the, how we can declare this? We know that we can write here, for example, asterisk ptr. Ptr is the name of the pointer. Okay, ptr is the name, and asterisk tells the compiler that ptr is the pointer, because this asterisk symbol tells the compiler that ptr is the pointer, and what it will go to store. Actually, the pointer stores the address of another variable. S is the variable, or we can say object. That means address of S. Address of S. For example, take here. Here, it means that ptr is the pointer that stores the address of S. This is S. For example, this is S. S, for example, 100 is the address of the S. 100 is the address of S. What does S contain? S is the variable. S is the variable, or S is the object which has 3 members, because this S is the data type of S is subtract student. Data type of S is subtract student. Complete subtract student is the data type, not only a student or a subtract. Complete subtract student is the data type, user defined data type. Subtract student S, that S is the variable. S is the variable, or S is the object of type subtract student. What does subtract student contains? It contains 3 members: roll number, name, and marks. For example, here I can write it. Roll number, name, and marks. That means this S, what is S? S is the, for example, this is 1000, is the address of this, that means this 1000 points to this location. What does, we know that S is the, actually what is S? S is the name of the variable. Name of the, what does name of this array? What does name of the variable contain? It contains the base address of the variable. The name itself contains the base address. Here is the array. It contains the name of the first address of the first byte. What is the address of the first byte? That is 1000. 1000 is going to be stored in S. That is internal pointer. S is the internal pointer. But now I hope you have understood. What would be the data type of this pointer? Because ptr contains the address of S. What is the address of S? For example, ptr is the under variable here. Ptr. I have declared here ptr, a variable that contains address of S. What is the address of S? Address of S is 100. That means this points to this location. 100 points to this location. क्योंकि अच्छा पता है इनके वेरिएबल आसान थी तिम एड्रेस बेकी वेरिएबल एड्रेस करान स्टोर जितन एस वेरिएबल एस वेरिएबल पीटीआर पॉइंटर क्योंकि पॉइंटर करान पॉइंटर मुझ हकान खाली एड्रेस स्टोर कर उछ वैल्यू हकान स्टोर कर तिमन मुझ के क्योंकि एड्रेस ऑफ एस छु 100 कसान स्टोर कत मुझ पीटीआर तिकाज एस इज द पॉइंटर एस पीटीआर द पॉइंटर ऑफ टाइप subtract student. Subtract student pointer PTR. That is PTR is the pointer that of type subtract student. Subtract student वो ये में pointer है S. That contain the address of S. S address क्या है 100. That is going to store in S. Okay. For example, here only I can initialize their values. For example, first 101 Yousuf 90. Here only I have initialized. This is a compile time initialization, which I have already discussed in the video number 1 of the video number 2 of this structure. That S, what is S? S is the variable, or S is the object of type subtract student. That means this S is the object of this structure, and this S contains 3 members because it's subtract student. What does subtract? It contains 3 members: roll number, care name, and float marks. Roll number, name, and float. Here I have declared as well as initialized the object. This S, I initialize it 101. That means 101 is the roll number, name is the Yousuf, and 90 the marks. Obviously, this is the base address because the name of the variable here contains the address of the first byte. Address of the first byte is 1000, and roll number is of type integer. That means it contains 4 bytes. It occupies 4 bytes of the space. 1000, it is 1004, and then care name of size 20 bytes. That means one care occupies 1 byte of memory, and 20 can 2. That means it may be 1024, and marks for 1. That is it. So this is the address of this byte, address of this byte, and this address of this byte. And this S contains the address of the first byte. That means address of the first location. That is 1000. And this is the pointer. Pointer contains the address of another variable. S is the variable of type subtract student. And PTR contains its address because address of this S is 100. Okay. Take care. Now we can access. How? Now I hope that you have understood what is pointer to structure. This is the pointer to structure. Here I have declared a PTR. PTR is the pointer that contains the address of the data type, whose data type is subtract student. Address of PTR is the pointer that will hold the address of the location, or you can say address of the data, address of the variable, whose data type is subtract student. And here I have also initialized. This is a declaration as well as initialization. I have here initialized this PTR with address of S. What is address of S? That is 100. 100 is going to store here. So now, how we can access the variables, these variable members? Because S has 3 members: roll number, name, and marks. How we can access these variable members through this pointer? Take care. For example, what is the first is an integer. Okay, 101 is integer. What is specifier? Format specifier of this integer is percentage D. Percentage D. For example, I want to access this first location, roll number, percentage D, then get percentage D is the format specifier for integer, then name of the variable. What is the roll number? Now, name of the variable, S, this dot roll number. sorry. PTR. We can access their variables, we can members of the structure through their pointers, just like this. Here, what does this mean? Percentage D. What is percentage D? That's the format specifier for integer. PTR. What is PTR? Is the pointer to roll number. Pointer to roll. What does this mean? Arrow. This arrow symbol is used to access the members of the structure, members of this object through pointers. PTR arrow. Take care. This. It is equal to, if we see that, what does this mean? PTR, it is equal to, for example, PTR dot roll number. Take care. This PTR arrow is equal to this. What does here this mean? It is the indirection operator. Here, this asterisk acts as an indirection operator. Because I have also already told you that at the time of the declaration of pointer, this tells the compiler that PTR is the pointer. But in the program, whenever it used in this program, other than declaration, this asterisk symbol acts as an indirection operator. And what does indirection operator returns? Indirection operator returns the value at the pointer. What is the value stored at that address? Value at address. We know that. What is this? PTR. That means, what is this? This tells the value at PTR. What is the value at PTR? PTR is this. What is this? This is the PTR. PTR is the, what is value? Value here is the 100. Value is 100. Because not address. Value at PTR. That is 1000, sorry. That is 1000. Value at 100 address. Because address is 1000. What is the value at address? That is 100. Dot roll number. That means this. It will return as 101. 101. Because I have already told in the previous video that we can access the members of the structure through the by using the dot operator. Dot operator is used directly to access the members of the structure. Members of the structure through their objects. Here I have used the pointer. I have used the pointer to access the members of the objects of the structure. Because this object or this variable contains three members: roll number, name, and marks. Here I have indirectly I have used here the pointer PTR. This pointer to access this value. That means this instruction printf %d PTR, this arrow symbol, the roll number, it will return, it will display, it will return 101. Similarly here, this will return 101. This instruction and this instruction is the one and the same. I hope now that you have understood. Now for example, we want to print a %s of, because second is the name, PTR arrow operator, and simply the name of the structure member. And similarly, we can write here this % float f PTR dot marks. That is it. So here I hope now that you understood how to access the members of the structure through the pointers. How to access the members of the structure. We can access the members of the structure through two ways. Either directly by using the variable and by using the dot operator. At that time we have to use the dot operator and the variable name. S dot k. For example, we can also access this. For example, printf %d s dot roll number. This instruction and this instruction and this instruction will generate the same type of the output. Same type of the output. Now it is clear how to access the members of the structure through their pointers. Or we can say, what is pointer to structure? Now you will be familiar about how to use the pointer to structure, or what is structure pointer. What is structure pointer? And inshallah in the next video we will discuss one more program based on this pointer to structure or structure to pointer. Actually, what does pointer contain? Pointer contains the address of another variable. Here, this pointer contains the address of the variable of type this structure student. Because this whole complete structure student is the data type. It is user defined data type. And S which I have declared here, is the variable of this type or object of this subtractor student. And this subtractor student contains three members: roll number, name, and float marks. Here, S. What does S mean? S is the name of the variable. Actually, it is the internal pointer to this array. It contains three parts. 101 is the name, this roll number, name, and marks. I suppose here the 1000 is the address of this first byte, and it is going to store in S because it's the internal pointer. Actually, the name itself contains the address of the first byte. And assume here that 100 is the address of this, and it is going to store in this pointer ptr, because I have declared here ptr a pointer of type subtractor student, and I have initialized it with the address of S. Here the address of S is 100, and that is going to be stored here. And we can access the members of this S, this variable, through the pointers by using this arrow operator. Here I have explained it that this means the indirection operator. That means the value at address of ptr. Address of ptr is, what is the address of this? Value at address. 100 is here, and this is the address of S. What is the value here? It is 1000, and the value at this 1000 is 101. Value at address. This is the address, and value at address is, it is going to point this, and it will dot rule number. And this is pointing to 101. 101. Okay. Now I hope that you have understood this concept fully, and inshallah in the next video we'll discuss some more examples of this same type. The next video, take care. Bye bye.